Beautiful design.
Innovative.
Scalable.
Secure.
Agile.
And lightning fast.
Welcome to the world of Salesforce Einstein.
Please welcome Leah McGowan-Hare, Senior Director, Trailhead Evangelism.
Hello, hello. How you all feeling? How's TDX going for everybody so far? All right, awesome. Well, I am honored to be here with you all, and I'm excited to share with you that Salesforce Hearts DX. Now, before we get started, I want you to take a moment and allow me to thank each and every one of you. I always like to start whatever I'm doing, whether it's personal or professional, to start whatever I'm doing from a place of gratitude. And I truly mean this, that I want to thank you all. I want to thank our customers. I want to thank our partners. I want to thank our employees. I want to thank all of our Ohana for creating and making Trailhead DX the success it is today. I mean, this is our 4th annual conference. Who was ever at the first one? Yes, so you guys are OGs. So you know we have come a long way, and I thank you all for making it a success. Now, I'm super excited, and I'm giving you all the permission to tweet, the permission to show your excitement. We have amazing speakers that have been working hard to share with you our vision, our innovation. So if they say something that resonates with you, that kind of moves you, it is okay to clap. You can snap, you can clap. If you want to get up in the aisle and do a dance, we are not judging you. If you want to go ahead and tweet, please tweet #CodeGoals. We're excited. We got lots of good stuff. Now, I have a little something I want to let you all know. Did you know you all are pretty awesome? And I'm going to tell you why. Because we have over 6 million Salesforce developers, which is 6 times the population of San Francisco. Just think about that. Yes. Over 240 Salesforce developer groups, and you guys are creating a vibrant, innovative, collaborative, inclusive Trailblazer community. And you know what that equals? That equals 100% awesome. Yes, it does. So now, I want to talk about our platform. Our platform was built to scale, and I have the numbers to back up that statement. With over 25 billion daily requests being handled by Heroku, and 8 million customer-facing apps on Heroku. And what about our environments? Well, we are refreshing over 600,000 sandboxes annually. That's a lot. And 1 million scratch orgs deleted. Now, this is the power of a platform at scale. And did you know 6 months ago, it was only 6 months ago, in January, we released Lightning Web Components. And today, we have over 200,000 Lightning Web Components deployed. Y'all ain't playing. You guys are out here making it happen, yes. And you know, when we first started for over the last couple of years, we've been focusing on the essentials. We're nailing that, right? The basics: plan, code, build, test, release, maintain. The basics of development lifecycle. And it only feels like yesterday I was on this stage, well, not this exact same stage, but like several years ago, 2017, announcing the beta of Salesforce DX, where we were focusing on source-driven development, modular design, agility, all of that. And we know technology is constantly changing. We know customer expectations are changing. And we realize our vision needs to include all of the different ways that you're building on the platform today, declaratively and programmatically, to meet those expectations. And that's why we heart DX. We heart DX. DX, developer experience, is all the tools and all of the processes that you all are using to build, innovate, and create on our platform. Now, our vision initially for DX included source-driven development, check, got it. Modular design, check, got it. Open and standard bases, we were giving you agility to use the tools that you enjoy working with. We got that. We now want to expand that vision to include the needs of admins and architects that are also innovating and creating on our platform. Like Suzanne from Boston Scientific. She was in the main keynote today talking about her journey. She started off as an admin, moved to a developer, and now is on the road to architect. So we want to make sure that our tools are also including flexibility, collaboration, collaborative tools, and productivity. And we're going to do this with the help of all of you all, with your feedback, all of your giving back, and we have so much amazement happening up next. Now here's the thing. We have 3 chapters of goodness, of down-home goodness you're gonna love. And those 3 chapters, the first one is gonna be on open. What does that mean to you as a developer, and what does that mean for us at Salesforce? And I'm working hard not to do any spoiler alerts because we got some good stuff coming there. And continuous, Claire is gonna bring it. And we got some continuous integration, continuous development info for you. And then we got productivity. We got all kinds of stuff, tools that are gonna help you be more efficient and more productive. So I know you're beaming and you want more and more. Well, we're getting there, hold on. First, I'd like to introduce our demo drivers, Kevin Hill and Rob Duffy. Wave it up, give it up. They're gonna be bringing us through this experience. And with further ado, I would like to bring up our first speaker, Kevin Venkateswaran. I said, who's gonna talk about open? I tried, Kevin.
Thanks, Leah. So let's talk about opening up the Salesforce platform. As an architect at Salesforce for nearly a decade, part of my role is to reflect on how we build software, how we benefit from open source, and how we give back. And so when we built Lightning Web Components, we designed it around open and modern web standards, like web components and JavaScript. We built it using open source tools like Babel, JS DOM. And that's one of the many reasons why I'm so thrilled with our open sourcing of Lightning Web Components. Salesforce loves open source. We're built on open source, and we've started many projects. And so our opening of the Lightning Web Components framework to you is one of many steps along that journey. As you heard today, that opening of the Salesforce Lightning Web Components is focused really on the core engine today. It's the first step of our journey. It brings to you information about and transparency of the core engine itself. It brings transparency to our roadmap. And it also brings and enables you to learn about how the internals of the engine work, to understand that code, to give back code to the project and to the community, and to help drive our roadmap. Open sourcing LWC enables you to build Lightning Web Components on and off the Salesforce platform. It allows you to apply your existing Salesforce knowledge to build web components outside of Salesforce. That's pretty great. So why don't we do that together now, as a group? So I'd like to thank Kevin and Rob for helping with the demo today. So what Kevin's brought up here is a mock-up that our design team gave to us to build an app around national parks. So let's decompose that. Let's take a look at what this app actually is made of. At the very bottom, we've got the grid. Inside of that grid, we've got all sorts of data. Now, I know of an open API from National Park Services that we can use to fetch that. And for that grid component to present all that information, we're going to use a third-party web component. Lastly, in the middle there, we've got the search box. So let's author that web component using Lightning Web Components. So we're going to start by using a tool called LWC Create App. Now, this app was created by a developer evangelist at Salesforce who is very excited about Lightning Web Components. And he decided to open source it. So you can go and download it today, give it a try, and you can even contribute code back to it. And that's what I've gone and done here. So as Kevin is showing up here, I issued a pull request this morning, adding some new capabilities to that. And that's the power of open. So Kevin, why don't we launch that command? And what it's going to do is it's going to ask us a few basic questions. Name, description, our author, and so forth. And we're just going to accept the defaults. And what it's going to generate is scaffolding for a project to build web components for us. So as that runs, let's open up one of the projects that Kevin and I created earlier. So this should look familiar to you. And I'd like to draw your eye first to that search box folder. It looks a whole lot like Lightning Web Components. We've got 3 files in there, right? The CSS, the HTML, and the JavaScript. So let's open up that JavaScript file and look at the first thing that we do anytime that we build a web component on the Salesforce platform. You see that familiar @API decorator. That helps us define what exactly the API is of our component, where all the inputs we accept and all the points of configuration. So we have up there a button label, some placeholder text, and some auto search capabilities. That's going to trigger searching automatically whenever the user types. So the next thing I'd like to draw your eye to is that dispatch function he's highlighting. So anytime a search is triggered, we're going to dispatch a standard DOM event called search with a payload of our search string. Our app's going to listen for that and respond to it. So we've implemented other logic, but I'd like us to go ahead and proceed, and we're going to build this web component. Now, because we're developing locally, we're just going to do a local link of that against our main project. But we could just as easily publish this to an internal registry or to one of many registries for web components on the internet. Now, Kevin's gone ahead and opened up our main project. This is our main app that we're building, and it's a standard HTML app. It's got some CSS and some images for aesthetics, but otherwise, it's just HTML and a little bit of JavaScript. So what he's focused on here is this use of this WC search box element. It looks and feels like a standard HTML element because it's just a web component, and that's the web component we built. We're going to configure it using the parameters that we just defined. And if he scrolls down a bit, we're going to see that third-party component that I mentioned before, this AG grid. This is a third-party web component we've decided to pull in, and it's going to present all the information for us. Now let's transition and take a look at that JavaScript. So at the very top of the JavaScript file, he's going to highlight is the URL of the open API we're going to call. That's against the National Park Services API. And below it, he's gone and highlighted that handle search function. That's where we're going to listen for that search event from our own component. Every time we receive it, we're going to notify the grid and request that it does the search for us. So Kevin, why don't we start up a local development server and take a look at what we've built. Opens it locally in a browser, and here we have our app. We've got the images, we've got all sorts of data from that public API. And there's a lot of lists there. There's a lot of parks in that list. And so Kevin, why don't you search for one of your favorite parks? And as he types it in, lo and behold, that standard DOM event fires, we receive it, we pass it to the table, and we get the park that we expect to see. That's pretty incredible that we just built an app in just a few minutes together. So let's recap. Let's recap exactly what we did. We built a web component using our existing skills of Lightning Web Components. We integrated it with a third-party web component, and we called an open API. We fetched and brought that all together, and we ran it on a local machine. So we invite you today, as we announced, to go visit lwc.dev, download and install Lightning Web Components, build web components with it, share them with us, share it with the community, contribute code back, and understand how that engine works. Now, while you're digesting all the possibilities that come with open sourcing Lightning Web Components, I want to give you a few more updates on some other initiatives we've got. First off, let's talk about Heroku. So that app that we just built and we ran locally, we could also deploy to Heroku. And that's done easily with a git push command. That's all it takes. And the reason it's so easy is because of Heroku build packs. And they provide a build pack for Node out of the box. Now, what's a build pack? A build pack is just a configuration of the tools and environment that your app needs to run in production. You could go and pick one from Heroku, You can build your own, choose one from the community, and you can basically make any language in any framework run on Heroku immediately. In the spirit of openness, it's one of the reasons why we also launched cloud-native build packs as well, allowing you to generate standard Docker files. Also from Heroku, we've got Oakcliff, the Open CLI framework. Now, we built this framework to make building high-quality command line interfaces extremely easy, to abstract away all the complexities. And we used it to build both the Heroku CLI, the Salesforce CLI, and in fact, that CLI that we use, that LWC Create app we just used in our own app, also was built on Oakcliff. And that's why I was able to generate a PR just this morning so easily, because it abstracts away all the complexities of building a high-quality CLI. So check out both these projects. If you're working on a CLI, highly recommend that you check out Oakcliff, and they've got a conference this Friday as well. Now let's also talk about how we're opening up the Einstein platform. So last year, we announced the open sourcing of Transmogrify. Transmogrify means to transform something in a magical way, and that's what we did with, and that's rather what Transmogrify does with standard structured data. So Transmogrify is an auto machine learning library that understands your structured data in your org. We're excited to open this project for a couple of reasons. And one of them is because as we built out the Einstein platform, we had to tackle some of the toughest challenges of enterprise AI. It's things like building customer-specific models at scale. So by open sourcing it and bringing the right abstractions to you, we empower you to build both quickly and effectively and at massive scale machine learning applications. What's incredible about Transmogrify is in about 3 lines of code, you can do data cleansing, feature engineering, and model selection automatically. I think that's pretty incredible. We recently launched a new site called opensource.salesforce.com, and I'm thrilled about it. As I mentioned before, Salesforce values open source. We're built on open source, and we give back to open source. We have more than 100 engineers working on over 1,000 projects every year contributing to open source. And we're thrilled by that. And we're thrilled that and excited and invite you to come join us, contribute to these projects, contribute to the community, and help us build software that we can all share together. With that, I'd like to invite up my colleague, Claire Bianchi, to talk about continuous innovation, integration, and delivery.
Thanks, Kevin. I'm here to talk to you today about application lifecycle management, and most importantly, how we're making it continuous and automated. The lifecycle of your application is continuous. You make your changes, you test them, your team reviews them, they move through a series of orgs until ultimately they wind up in production, and you start the process all over again. DX tools enable you to automate this whole process and have added modern capabilities that allow you to find bugs faster, work better as a team, and maintain your source of truth outside of your org. That's the dream. But is the reality? I think we can all relate to pushing your changes to production to ultimately find a bug that you missed. Maybe you did automated testing in some way and you forgot to run your Apex tests, or you missed a use case in your manual testing. However it happened, the bug is there. We also know the solution to this problem: automated testing, also known as continuous integration. Something that we've been able to do with Salesforce DX tools for a while, but requires expertise to master. The hard part is setting it up. Once it's ready, it's easy, automated, continuous. So how do you get started? The first step is translating the Salesforce development workflow to the continuous integration and delivery workflow. So what does that look like? At a high level, here is a diagram of Salesforce and continuous integration. Look familiar? It looks like every other continuous integration diagram that you've seen, but the devil is in the details. Here at Salesforce, we actually have two development workflows, org-based and package-based. If you're doing org-based development, you're making your changes in a sandbox, and your source of truth is your org. If you're doing package-based development, you're making your changes in Scratch orgs, and your source of truth is a version control system. Both of these workflows can be continuous and automated. So the next thing you have to do is write your automated testing scripts, set up your tools, and figure out when and where to run your tests. I know, the hardest part is getting started, but I want to show you how we're making it easier. Kevin and Rob are going to help me walk you through how we're making continuous integration easy with GitLab and SFDX. So I'm a developer at eBikes, and we've been tasked with setting up automated testing with our Salesforce org. The problem? I don't know anything about continuous integration, and I don't know where to begin. Luckily, I've heard about the new integration between SFDX and GitLab. So I head over to gitlab.com, and I'm able to sign in with my Salesforce credentials. Sweet. So once I sign in, I head over to the new SFDX group within GitLab, which is at gitlab.com/SFDX. And there I find some templates that help me get started quickly. Here's the project template. This comes with everything that you get from when you run the project create command, plus it's already set up with continuous integration out of the box. It has directions on how to import this and create your own repository, and here is that continuous integration file already set up. Now, when you look at it, it's really short for a fully automated continuous in delivery script. But that's because it's calling the other repository, which has the continuous integration script in it. So in this repository, you'll see the README walks you through what is happening at each step in the continuous integration pipeline, where we're running your tests, why we're running them, and what happens in each environment. It also tells you how to authenticate into your org. So Kevin, Rob, and I take our time, we put together our org, and now we have our eBikes repository. So here's our eBikes repo, and let's go to a pipeline that's already run. So we've run a whole bunch of pipelines recently. So here's one that's gone all the way through to production. So you'll notice the first thing we're doing is we're running your LWC tests locally. We're going to create a Scratch org. We're going to run your Apex test. That Scratch org is created as an environment you can do manual testing in as well. And then when we're ready, we'll deploy to the sandbox and then ultimately to production. So now we're ready to make a change. So because we're using package-based development, we're going to do that in Scratch orgs. So I'm going to open a Scratch org that we made earlier today that already has the eBikes app in it. And we can do this from the Salesforce command line. So here's my org, and we're going to navigate to the eBikes app. And then we're going to go over to the Product Explorer page. We've been doing some testing at eBikes and have found that the most optimal version of this page is actually to have the filter on the right-hand side. So Kevin's going to go ahead and make that change for me and save it. Again, because we're using Scratch orgs, we're tracking changes between the Scratch org and your local environment. So we're going to return to the CLI and pull those changes down locally. This is the power of a Scratch org. You don't have to remember what you've changed. The Scratch org remembers for you. So now that we've got those changes locally, we can commit them to our repository using Git. And because I have continuous integration and delivery already set up with GitLab pipelines, it's going to kick off the pipeline when we go back to the repo. So let's go back to GitLab, back to our eBikes project, and let's see what we've got in our pipelines. Boom, we're running a new pipeline. So you'll notice this one's a little bit shorter than the last one I showed. That's because we're committing to a branch, which is best practices, and we want you to run all of your tests, do all of your manual testing, and do a code review with your team before you merge to master. And so that's what this is doing here. And the YAML file that I showed before already has that all set up. You don't have to figure it out. So that's how easy it is to set up continuous integration and delivery with GitLab and Salesforce. Thank you, Kevin and Rob. So while I've been working with the GitLab team, making setting up continuous integration easier, the rest of the team has been adding more enhancements to our development workflows. So what's new with package-based development? This release, we're launching Preview Scratch Orgs. This means you can now test your app in the next version of Salesforce. You can even add a stage to your continuous integration pipeline so you test on the next version of Salesforce before it's live. Awesome, right? Packaging is also getting some sweet new enhancements, including the ability to run the Apex debugger in all unlocked packages, and the ability to specify if you want your Apex to compile just in your package or on your whole org at install. This comes in handy if you're testing out moving to package-based development on a really large legacy org. So what's new with org-based development? As the product owner of the Salesforce CLI, I'm excited to announce that org development commands are going GA. Woo, yeah. We introduced these commands at Dreamforce last year, and they introduced the ability to use source format in sandboxes. Source format organizes your metadata into an easy-to-read file structure. This means you're working on nuggets of code instead of large swaths of metadata, which is really hard to read and find bugs in. We've been listening to your feedback during the beta period and have added the ability to deploy to production. In fact, now you can use these commands in any org, so you never have to use metadata format ever again. Woo! This release, we're also adding the ability to create a sandbox from the CLI, so you can do continuous integration and delivery in a modern fashion, even with org-based development. So all of these enhancements make being continuous with Salesforce development workflows easier, but as I said before, the hardest part is getting started. And that is why we partnered with the GitLab team to create easy-to-use templates that make setting up automated testing out of the box easy. So the GitLab team is here. So Salesforce, meet GitLab. GitLab, meet Salesforce. The GitLab team actually helped us write a new trailhead that walks you step by step through setting up continuous integration and delivery with GitLab and SFDX best practices. We are also offering 3 months of GitLab Gold for free for Salesforce customers. Finally, if you'd like to see this continuous integration and delivery in action, I'm doing a dedicated session with the GitLab team tomorrow morning at 8:30 a.m. So being continuous improves the productivity of your team because your testing is automated. I'd like to welcome my friend Nate Totten to the stage to talk about the other things we're doing to improve developer productivity.
Awesome. Thanks, Claire. So I want to talk next about productivity on the Salesforce platform. Whether you're an admin, a developer, whether you're low code, full code, it's important that you have access to the most productive and enjoyable tools to do your job. So I want to talk a little bit about those tools. First off, let's start with Heroku. Many of you use Heroku Enterprise in your organization. You use Heroku Teams to manage accounts and permissions in your environment. We've heard a lot of feedback from you that you need more control control over security, compliance, and you want to move to a more self-service model. Today, I'm happy to announce Heroku Enterprise Accounts. Enterprise Accounts deliver on that, bringing you more control, security, and reporting around auditing so you know who and what is happening inside of your environment. Heroku Enterprise Accounts is going to be in beta tomorrow, and it'll be GA sometime later this summer. So let's switch over now to the Lightning platform, specifically our developer tools. 2 years ago at Dreamforce 17, when we announced Salesforce DX, we shipped our first release of VS Code in the CLI. Since that time, we've shipped over 150 releases. And in fact, since we were here just last year at Trailhead DX, we've shipped dozens of new features, including things like org-based development and Apex refactoring. Lots of really cool things. Another bit of news that I'm really excited to announce is that our internal engineering teams are now actually using the Salesforce extensions for VS Code for developing Aura and LWC. So when they're writing on our core internal platform, or when our teams are writing apps on the platform, like Idea Exchange, they're using the same tools that you are using. This is really going to help everyone improve the quality of the tools that we all use every day. So I spend a lot of time talking with you, talking about how you use our developer tools, what you like, what you don't like. One of the things that I hear a lot is that you want us to make things faster. You want everything to be fast. Sometimes it's true that developing on our platform can be a little tedious. The time between when you hit save on your code and when you see things running in the environment is a little bit long. We have a number of things we're working on to make that faster. But the one that I'm really, really happy to share with you today is local development. Rather than talk about this, I think it's best to just see it in action. Great. So Rob and Kevin are still back here plugging away at e-bikes. They've been working on some LWC code, and they're kind of to the point where they want to test some stuff out. Now, normally, we'd deploy that to our org, Scratch org, Sandbox, whatever. In this case, though, we're going to start our LWC local development server. And in just a second, we see our environment spun up, and we're ready to go. There's a couple things on this page. This is our LWC server landing page. The most important thing, though, is our list of components. So let's click on a component and see what's happening. Great, we've got our component rendered locally. Pretty cool. You may have seen this morning in the keynote. We could make changes, see that refreshed in the browser immediately, but I want to move on and see some more interesting things. So let's click on another component that Kevin's been working on, the product filter. He made a mistake, as tends to happen. So in LWC local development, we give you a beautiful error page that shows you exactly what error occurred, the file that the error occurred in, and we even highlight the exact line on which the error occurred. This is going to make finding and fixing bugs in your LWC components in the JavaScript much easier. No more deploying, finding what's wrong, and repeat. Better yet, there's a link inside of this page you can click on to actually open the code right to the file and the line where the error occurred, making it super easy to fix. So Kevin is a really good developer, and so he's fixing the error, and you'll notice here he has really rich code completion for LWC. So we're giving you code completion for everything, and this includes the objects and the fields inside of your org. He's going to refresh after he hits save, and boom, it's working. Super easy to fix without deploying to the org. Another thing to notice on here is this component actually has data. The LWC local development server connects from your local machine, proxies requests to the org in which you're connected, giving you a near complete developer experience on your local machine. Just to prove that this is real, Kevin's going to go in the Scratch org and add a new pick list value. He promised not to surprise me with what he wrote. And we're going to refresh it and see, boom, our new value is there shown. So developing your LWC app on the platform isn't just about single components. It's also about how they work together, how they interact together, which is why we've also enabled Flexi pages to run locally. He right-clicks on the Flexi page there, it starts up and launches our page here, where we see our 3 components, the product filter that we're working on, or we were working on, the product list, and our product card, all loaded with data. Additionally, he can click on it, interact with it, and see things working. Great. Again, all of this was done without a single deployment to the org. Cool. Now we're ready. We can finally deploy this for the first time and do our final check and verification. Pretty cool. Slide, please. Thank you. So, we saw a couple things, just to recap. First off, we can render components locally. When you make a change, they'll refresh in your browser instantly, no deploying to the org. You get a beautiful error message that shows you exactly the errors that occur, what file the error is in, and even what line the error occurs on. This will make it really easy to find and fix bugs. We've shown you how you can connect with data in your org, whether that's custom objects, Apex controllers, etc., and how you can render multiple components together on an entire Lightning page, all without a single deployment. So we've talked mostly about what we're going to deliver soon. I wanted to switch gears here and talk a little bit about the future, about where we're heading. First off, with LWC development, oh, I missed a bit. We're going to be shipping this, sorry. I know the thing you're most excited about is when you can use this thing. So it's getting close. It'll be ready for you to use this summer. So stay tuned. It's going to be awesome. Now let's talk about what's next. So first off, with LWC Dev, after our first release, we're going to work on the ability to actually mock data and services locally. This is going to help further disconnect your development from the org and help build really powerful tests for your UI applications. With VS Code, we're going to bring the ability to compare diffs of your local source with what's in the org, and we're going to ship the capability to detect and merge conflicts when you deploy and retrieve from or to your org. We'll also, yes, I know everyone's been asking about that one. And we're also bringing full code completion for SOCL, making it really easy to write queries in VS Code. And we'll be working on profiling tools to help you write super performant code to build really fast applications for your customers. From the CLI, we're working on expanding our plugin ecosystem, and we'll be shipping data synthesis tools. Finally, we're going to be shipping hooks, which will help you really even further customize your developer workflow with the CLI. Finally, we know that not everyone in here uses our desktop-based tools. Many of you spend your day in web-only tools like the Dev Console. Over the next year, I'm happy to say that we're bringing LWC development, source-driven development, and even package-based development to the web. We believe it's super important that everyone, no matter which tool they're using, no matter where they're running that tool, has access to the same amazing and productive developer experience. And with that, I would like to welcome Leah back to the cloud.
All right. Oh, let me get my... Thank you, Nate. Oh my gosh, my mind is still like, that was amazing. I mean, open, LWC, being able to create these components off platform, CLI with GitLabs, another mind-blowing thing. And then local development, I mean, there's just so much goodness in all of this. And a lot to remember, but here's the beauty, you don't have to. Because guess what? We have Trailhead. And you can get out there, start this trail mix, which will have all the things that we've covered here. So now you heard it, and now you want to take it in, you want to get in and do some actually kinesthetic learning and learn about it, you can do it on Trailhead. Please take a picture of that URL, and I'm expecting everybody in here, I'm assigning homework, everyone in here is gonna go out there and finish up that trail mix. Now, the learning doesn't stop here. This is just the beginning. We want you to continue on this journey and hear more. We've got some great stuff. Please make sure you check out the campground. And we have an amazing session tomorrow at 11 o'clock, low code. We went straight up code here, but to be a holistic developer on the platform, you also got to know about low code. So we have our low code super session tomorrow at 11 o'clock. And then tonight, of course, how many are going to Macklemore? All right. So I don't know how early I'll see y'all tomorrow morning, but 11 o'clock, I think you can make that happen. And get hands-on. And we really do want your feedback. I cannot wait to see what you do with our open source Lightning Web Components. I'm just amazed already about what you're going to be building on that. So with that, I want you guys to go out, enjoy the rest of your day, and I thank you.